So and here's the result. The spiny waterflea is very widespread in this watershed. But all the red lakes are lakes that we now know have been invaded by the spiny waterflea. This really is ground zero in North America for this invasion. When we started, we first found them in Lake Muskoka, Russell and Joseph in '89. We got quite excited for a few years, found them in all the bigger Huntsville lakes. And then there was kind of this slow accumulation of unplanned observations for about a decade. Got really serious in 2004 and said, we're missing something big here. And so here's 2005, 2006, and in 2 years of work, we tripled the number of known invasions in the watershed. I also am breaking a rule that Jim also broke that I said you should never do with the public talk, which is show a multivariate plot like this. But Jim introduced it, so that's great. So it's his fault, not mine. There's 311 squares on this graph. Each square represents a lake. And believe it or not, each square is organized around 10 variables. The organic carbon, the phosphorus, the pH, there's a temperature in here, there's Secchi depth, there's lake depth, I can't even read that. That's lake area, size, alkalinity, calcium conductivity. The critical thing you need to know is lakes that are close together have the same chemistry, and phosphorus and DOC that are close together, that means those two lakes have very high phosphorus and DOC. These lakes up here have high alkalinity, high conductivity, high calcium. So the take-home message is the red triangles were the invaded lakes, and they're not randomly distributed around Muskoka. They are, in fact, found in deep, clear water, big lakes that have low phosphorus and DOC, not high phosphorus and DOC. And so there's a subset of habitat conditions where we found the spiny waterflea. Now, the most interesting question really is, okay, if those habitat conditions will support the spiny waterflea, why aren't they all red? What is it about these other lakes, because there's more of them, that did not have the spiny waterflea than the red lakes that do? So let's just address that very quickly and look at just the lakes, the 60 or so lakes, 80 or so lakes that are within that kind of polygon. And here's one of my key take-home messages. It seems to be human use that distinguishes invaded from uninvaded lakes that have suitable habitat. Invaded lakes within that polygon, 70% of the shoreline was cottage. If the lakes were within that polygon but were not invaded, on average only 25% of the shoreline was cottage. I hope you can see the black versus the gray. The black are the invaded lakes. Lakes that were in that polygon that had public boat launches, 65% of them were invaded. If there was no boat launch, only 5% were invaded. If there were no motors allowed, only 5%. If motors were allowed, 70%. And I can't even read this one. What's that say? Oh yeah, protected. If the lake was protected, it was in a locked off and private or in Algonquin Park, if there was some sort of protection on the lake, but it had the right suitability or conditions, they tended not to be invaded. If there was no protection, 90% versus 10%. So if it was loons spreading them everywhere, or if it was mayflies spreading them everywhere, we wouldn't see these very strong patterns, I don't think. So there's a very strong suggestion that humans are involved in this spread. How are humans doing this? I'll just show you a few photographs. This is a spiny waterflea collected from a ballast tank by Huma Kaiser from Windsor. From Windsor, I was moving around the Great Lakes. We're sure that they came to North America in ballast, but we actually, and we've compared the genetics of the animals from here and the animals from all across Europe, and it looks like they came based on the genetics from Northwest Europe with a small other set from Northern Italy that must have come through the canal systems of Europe. But within the Great Lakes, they're being moved around in ballast tanks, and we've actually caught them in those ballast tanks. Bilge water in boats. We have not caught a spiny waterflea in bilge in a boat yet, but we've caught 13 other species and 10 zebra mussels from boats whose water we pumped in docks sitting in Lake Simcoe. But look at this amazing photograph. So this is a downrigger cable in Lake Erie, and there's like thousands of spiny waterfleas on that downrigger cable. So it's very easy for people to spread these things around. We'll come back to what we should do about that. Have they caused damage? So we know that they're spreading, and it looks like there's some human connection to that spread. Well, in what ways would we be concerned? Do they threaten people? Do they reduce fish growth? Do they increase sport fish contaminant levels? Do they change water clarity? Do they affect native biodiversity? The jellyfish seems to do none of these. That's one of the reasons why it's kind of cool having this little jellyfish. I don't have time to talk about most of these, except to say that we have no evidence that they cause disease or they sting you or anything like that. There doesn't seem to be any direct threat. The fish growth question is quite complicated and would take its own talk. So I'll just say there's some evidence of changes in fish growth. People are looking for increases in mercury levels in fish associated with the arrival of the spiny waterflea. We're not seeing any mercury effects yet. We had hints of effects of changes in water clarity, but those don't in Lake Rosso. Doesn't seem to have panned out though. But there is absolutely no doubt that there's a big impact on native biodiversity. So I'll just show you a few examples of that. Harp Lake is one of the main long-term study lakes that Jim mentioned, just east of Huntsville. Harp Lake has become an experimental lake because the spiny waterflea appeared in our samples in 1993 and may have showed up a year or two before. If you look at the biodiversity of these little water fleas, I almost feel I don't have to introduce them because I've talked about them so much before. These are the animals I call the little living lawnmowers in our lakes. There's about 20 of them in every liter of healthy lake water. The entire volume of Lake Muskoka is filtered through the stomachs of these water fleas every 10 days. It's because of them that our lakes are clear, in consort with how we manage our fertilizer application. We all know from lawns that the length of the lawn is a function of how often you mow and how often you fertilize. Lakes are no different. The lawnmowers are doing the mowing, and the septic tanks are doing the fertilizing to some extent. And so typically we had 6 or so of these species in a standard count of maybe 200 animals, 6 different varieties of these little water fleas in the summer in Harp Lake, but since the spiny water flea arrived, we have only 2. And every place we look in Ontario, here's a big summary of the loss of native crustacean biodiversity associated with the arrival of the spiny water flea. I think all you need to know, how's the time? Yeah, is that there's a very substantial reduction. Every place we look, like acid rain affected small lakes but not big lakes. Acid rain was really bad. We lost biodiversity in 7,000 small lakes in Ontario. But there was no impact on the Great Lakes of acid rain per se. If we start with Harp Lake, the pattern I just showed you, this was kind of an extreme example because I just looked at the summer data and I just looked at one group of the animal plankton. If we look at the whole year, and we look at all the plankton, not just the water fleas, we have a 20% loss when we compare pre-invasion to post-invasion years. I had a student, Stephanie Boudreau, that did the same thing, did a survey comparing, say, 15 odd invaded and non-invaded lakes, got a very similar number. Michelle Palmer, who isn't here tonight, has proved the same thing. When we go to bigger lakes like Lake Simcoe, there's been a 25% reduction in biodiversity in the open waters of Lake Simcoe. And I've been working with a guy called Rick Barbiero from the US to reinterpret a bunch of his data, and there's been a 20 to 30% reduction in the open water biodiversity of zooplankton in the Great Lakes associated with the arrival of the spiny waterflea. So there's no inconsistency in any of these data sets I've been able to assemble that if we care about native biodiversity, then the spread of the spiny waterflea is a bad actor. Okay.
5 minutes.
Okay. Why is that? It's in part because they can be very abundant. You can barely see these. This is a handful of spiny waterflea collected from the Rainy River out of a larval fish trap en route to Lake Winnipeg. The people I've been talking to in Manitoba environment are expecting this to catch the spiny waterflea in Lake Winnipeg this summer, which means it's out of the Great Lakes watershed on its way to Hudson Bay. So it can be very abundant, as you see with this handful. Here's a whole thousands of them on the shore of Lake Erie. It eats a lot, so it has a direct effect. It also drives animals out of warm surface water into cold, unproductive water. That's what's happening in Lake Muskoka, where these animals have much less room. And it can be very abundant. Tragically, you can't see this. This is the Cisco with 2,500 spiny waterfleas in its stomach collected from Lake Rosso. Maybe you can see the spines. So they were all faced in one direction, so when the stomach was was split open by Beth Clark. Years ago, there was the heads on one side and the tails on the other side, is what you saw. I can show you this a little later. Okay, what do we do? I'll end with what can we do. There are two questions to ask. Can we slow the spread, and can we eliminate known invasions? The answer to can we slow the spread is yes. We need to know where they are. I brought a set of 20 maps of our current understanding of where Bythotrephes is and 69 lakes in Muskoka that are at the back. And this, I assume, will be on the website, the talk. Please never move water between lakes, especially from lakes that are known to be invaded. You saw how many there were on those fishing lines. If you take any gear and dry it for 6 hours, make sure it's bone dry for 6 hours, that will kill not only any living animals, but it will kill the resting eggs, even resting eggs that are still inside their mothers. Took 2 years of work to do that. Not work that I've done, but work done by a guy called Don Brandstrader at the University of Minnesota Duluth. Chloride does not kill them. Chlorine bleach does not kill them. So don't just add chlorine and assume that you're safe. Drying will kill them, chlorine will not. Never dump a bait bucket with water in it, even if you think it's empty. The whole bottom could be covered with resting eggs of invading species. Just because you can't see anything in the water doesn't mean it doesn't contain threats. Be careful about cleaning fish. Resting eggs of the spiny waterflea are adapted to survive passage through a fish's stomach. They actually probably don't mind being eaten teleologically because it might end up spreading them from lake to lake. And if you think these are visible, these animals are a centimeter long. So not in your tea-colored lake you wouldn't see it, I don't think. It's just, but they've often been brought to our attention by cottagers. In fact, the first time we saw it in Muskoka was a lady on Penn Lake who brought her child's pink plastic bucket to the lab, and it had maybe 200 spiny waterfleas in it that she'd scooped off the end of her dock, and she said, "I've never seen these before." And we had neither, so that was 1989. So it's currently the Ontario Federation of Anglers and Hunters that's tracking the real spread of these invaders around Ontario. Can we eliminate known invasions? Everyone says no. Everyone says it's impossible. I hate that statement, and that's because no one has tried. No one has done the research. No one has attempted the deep biology that would have to be done to begin to explore whether it might be possible to eliminate it. We know for sure we can't do it now, but I think it actually would be possible to develop techniques where it could be done. Okay, here's this map that I put at the back of the room. It just lists the 69 lakes in the area, not all in Muskoka, some a little south, Halliburton way, some a little north, that we know to be invaded. This goes up to 2010. We're sampling 100 lakes this summer. We've got through about 30 of them. So far we have 5 known invasions. So it's still spreading, and so we really need to do our best to follow those rules to try and reduce the spread. I was in Halliburton a few weeks ago and we heard that it's not just in these lakes in Halliburton, it's in some other lakes as well. Okay, that's all I want to say. I'd like to acknowledge the Ministry of Environment, Storage, and Environmental Science Center, who supported this spiny waterflea work for many years when no one else would. The Ontario Federation of Anglers and Hunters has been supportive. The district for housing one of our crews, and the Canadian Aquatic Invading Species Network, who gave us the $150,000 we needed to hire those 10 people to do that 300 lake survey. Thank you very much.